This module will look at the purpose of the service operations stage. The purpose of the service operations stage of the service lifecycle is to coordinate and carry out the activities and processes required to deliver and manage services at agreed levels to business users and customers. Service operation is also responsible for the ongoing management of the technology that is used to deliver and support services. Service operation is a critical stage of the service lifecycle. Well-planned and well-implemented processes will be to no avail if the day-to-day operation of these processes is not properly conducted, controlled and managed. Service improvements will not be possible if the activities to monitor performance, assess metrics and gather operational data are not systematically conducted during service operation. The scope of service operation will encompass every aspect that affects the service consumption. This includes the services themselves and the activities that form part of the service. These are included in service operation, whether they are performed by the service provider, an external supplier, or the user or customer of that service. The ongoing management and execution of the many service management processes that are performed in service operation. Even though a number of ITIL processes, such as change and capacity management, originate at the service design or service transition stage of the service lifecycle, they are in use continually in service operation. All services require some form of technology to deliver them. Managing this technology is not a separate issue, but an integral part of the management of the services themselves. Therefore, a large part of the service operation is concerned with the management of the infrastructure used to deliver services. Regardless of what services, processes and technology are managed, they are all about people. It is people who drive the demand for the organization's services and products, and it is people who decide how this will be done. Ultimately, it is people who manage the technology, processes and services. With the purpose of targeting the delivery of service, the objectives of service operation are very clearly focused on supporting activities, namely, maintaining business satisfaction and confidence in IT through effective and efficient delivery and support of agreed IT services, minimizing the impact of service outages on day-to-day business activities, and ensuring that access to agreed IT services is only provided to those authorized to receive those services.
Good communication is needed with other IT teams and departments, with users and internal customers, and between the service operations teams and departments themselves. Issues can often be prevented or mitigated with appropriate communication. An important principle is that all communication must have an intended purpose or a resultant action. Information should not be communicated unless there is a clear audience, and that the audience should have been actively involved in determining the need for that communication and what they will do with the information when they receive it. This point can be clearly illustrated if we consider that at some points in our lives, some of us will have sent reports to people who had no need for the reports we sent and never told us. Likewise, we may well have been the recipients of reports that have no value for us. Pointless communications really need to be stopped and only useful, relevant communications accepted. Typical routine operational communications could include the following: handover communications between shifts, performance reporting from teams, communication within projects, operational communication related to changes or exceptions and emergencies, information and training on new or customized processes and service designs, regular communication between service strategy, design and transition to service operation teams. All required valid communications should be documented centrally in a communication policy document. This document should record details such as name of the communication, intended audiences, communication originators, communication format such as email, printout, SharePoint page, communication frequency, which would include timings such as daily, weekly, or monthly. This policy should be reviewed on a regular basis to ensure it is current and that all communications listed within are relevant, and also to include any new communications that would add to service quality.
Within the service operation stage of the service lifecycle, there are 4 functions and 5 processes that we need to consider. The functions are the service desk, application management, technical management, IT operations management. The processes are event management, incident management, request fulfillment, access management, and problem management. A function is a team or group of people and the tools or other resources they use to carry out one or more processes or activities. In larger organisations, a function may be broken out and performed by several departments, teams and groups, or it may be embodied within a single organisational unit, e.g. a service desk. In smaller organisations, one person or group can perform multiple functions, e.g. a technical management department could also incorporate the service desk function. For service operation to be successful, an organisation will need to clearly define the roles and responsibilities required to undertake the processes and activities identified earlier in the processes. Functions carry out one or more processes and activities. Activities consist of a set of actions designed to achieve a particular result. They are usually defined as part of processes or plans and are documented in procedures. There are a number of decisions to be made when deciding how to allocate activities between functions, and also a number of influences such as location, functional split, risk and straightforward finances. ITIL does advocate a standard or generic functional breakdown that should be applied rigorously. However, a number of key or logical functions have been put forward as suggested recommendations.
A service desk is a functional unit made up of a dedicated number of staff responsible for dealing with a variety of service activities, usually made via telephone calls, web interface, or automatically reported infrastructure events. The service desk is a vitally important part of an IT organisation and should be the single point of contact for IT users on a day-by-day basis. It not only handles incidents, escalates incidents to problem management staff, manages service requests and answers questions, it may also provide an interface for other activities such as customer change requests, maintenance contracts, software licenses, service level management, service assets and configuration management, availability management, financial management for IT services, and IT service continuity management. The value of an effective service desk should not be underestimated. A good service desk can often compensate for deficiencies elsewhere in the IT organisation, but a poor service desk, or the lack of a service desk, can give a poor impression of an otherwise very effective IT organisation. It is therefore very important that the correct calibre of staff be used on the service desk and that IT managers do their best to make the desk an attractive place to work to improve staff retention. The first structure we will consider is the local service desk. This is where a desk is co-located within or physically close to the user community it serves. This often aids communication and gives a clearly visible presence, which some users like, but can often be inefficient and expensive to resource as local staff are tied up waiting to deal with incidents when the volume and arrival rate of calls may not justify this. There may, however, be some valid reasons for maintaining a local desk, even where call volumes alone do not justify this. Reasons might include language and cultural or political differences, different time zones, specialized groups of users, the existence of customized or specialized services that require specialist knowledge, VIP criticality status of users. The second structure is a centralized service desk. Here it is possible to reduce the number of service desks by merging them into a single location or into a smaller number of locations by drawing the staff into one or more centralized service desk structures. This can be more efficient and cost-effective, allowing fewer overall staff to deal with a higher volume of calls, and can also lead to higher skill levels through greater familiarization from more frequent occurrence of events. It might still be necessary to maintain some form of local presence to handle physical support requirements, but such staff can be controlled and deployed from the central desk. The third type of service desk structure is the virtual service desk. Through the use of technology, particularly the internet, and the use of corporate support tools, it is possible to give the impression of a single, centralized service desk, when in fact the personnel may be spread or located in any number or type of geographical or structural locations. This brings in the option of home working, secondary support groups, offshoring or outsourcing, or any combination necessary to meet user demand. It is important to note, however, that safeguards are needed in all of these circumstances to ensure consistency and uniformity in service quality and cultural terms. Some global or international organizations may wish to combine two or more of their geographically dispersed service desks to provide a 24-hour follow-the-sun service. For example, a service desk in the Asia-Pacific may handle calls during its standard office hours, and at the end of this period it may hand over responsibility for any open incidents to a European-based desk. That desk will handle these calls alongside its own incidents during its standard day, and then hand over to a USA-based desk, which finally hands back responsibility to the Asia-Pacific desk to complete the cycle. This can give 24-hour coverage at relatively low cost, as no desk has to work more than a single shift. However, the same safeguards of common processes, tools, shared databases of information, and culture must be addressed for this approach to proceed, and well-controlled escalation and handover processes are needed. For some organizations, it might be beneficial to create specialist groups within the overall service desk structure, so that incidents relating to a particular IT service can be routed directly, normally via telephony selection or a web-based interface, to the specialist group. This can allow faster resolution of these incidents through greater familiarity and specialist training.
Technical management refers to the groups, departments or teams that provide technical expertise and overall management of the IT infrastructure. Technical management plays a dual role. Firstly, it is the custodian of technical knowledge and expertise related to managing the IT infrastructure. In this role, technical management ensures that the knowledge required to design, test, manage and improve IT services is identified, developed and refined. Secondly, it provides the actual resources to support the service lifecycle. In this role, technical management ensures that resources are effectively trained and deployed to design, build, transition, operate and improve the technology required to deliver and support IT services. By performing these two roles, technical management is able to ensure that the organisation has access to the right type and level of human resources to manage technology and thus to meet business objectives. The objectives of technical management are to help plan, implement and maintain a stable technical infrastructure to support the organisation's business processes through well-designed and highly resilient, cost-effective technical topology. The use of adequate technical skills to maintain the technical infrastructure in optimum condition. Swift use of technical skills to speedily diagnose and resolve any technical failures that do occur. Application management is to applications what technical management is to the IT infrastructure. Application management activities are performed in all applications, whether purchased or developed in-house. One of the key decisions that they contribute to is the decision of whether to buy an application or build it. Once that decision is made, application management will have several roles. Just as with technical management, it is the custodian of technical knowledge and expertise related to managing applications. In this role, application management, working together with technical management, ensures that the knowledge required to design, test, manage and improve IT services is identified, developed and refined. It will also provide the actual resources to support the service lifecycle. In this role, application management ensures that resources are effectively trained and deployed to design, build, transition, operate and improve the technology required to deliver and support IT services. By performing these roles, application management is able to ensure that the organisation has access to the right type and level of human resources to manage applications and thus to meet business objectives. This starts in service strategy and is expanded in service design, tested in service transition, and refined in continual service improvement. A key objective is to ensure a balance between the skill level and the cost of these resources. Application management also performs other specific roles, such as providing guidance to IT operations about how best to carry out the ongoing operational management of applications. This role is partly carried out during the service design process, but it is also a part of everyday communication with IT operations management as they seek to achieve stability and optimum performance. The integration of the application management lifecycle into the service lifecycle. The objectives of application management are to support the organisation's business processes by helping to identify functional and manageability requirements for application software and then to assist in the design and deployment of those applications and the ongoing support and improvement of those applications. These objectives are achieved through having applications that are well designed, resilient and cost-effective, through ensuring that the required functionality is available to achieve the required business outcome, organising the technical skills to ensure they are adequate to maintain operational applications in optimum condition, swiftly using technical skills to speedily diagnose and resolve any technical failures that do occur. Often, application development and management teams and departments have acted as autonomous units. Each one manages its own environment in its own way, and each has a separate interface to the business. Over the past several years, these two worlds are being brought together with growing pressure from the business to be more responsive and easy to work with. This means that application development will move towards accountability for the successful operation of applications they design, while application management will move towards greater involvement in the development of applications. This does not change the fundamental role of each group, but it does require a more integrated approach between application development and application management functions.
In business, the term operations management is used to mean the department, group or team of people responsible for performing the organization's day-to-day operational activities, such as running the production line in a manufacturing environment or managing the distribution centers and fleet movements within a logistics organization. The role of IT operations management is to execute the ongoing activities and procedures required to manage and maintain the IT infrastructure from two perspectives, so as to deliver and support IT services at the agreed levels. IT operations control oversees the execution and monitoring of the operational activities and events in the IT infrastructure. This can be done with the help of an operations bridge or network operations center. In addition to executing routine tasks from all technical areas, IT operations control also performs the following specific tasks: console management, which includes event management, monitoring, and control activities; job scheduling, or the management of routine batch jobs or scripts; backup and restore on behalf of all technical and application management teams and departments, and often on behalf of users; print and output management for the collation and distribution of all centralized printing or electronic output; performance of maintenance activities on behalf of technical or application management teams or departments. Facilities management refers to the management of the physical IT environment, typically a data center or computer rooms and recovery sites, together with all the power and cooling equipment. In some cases, the management of a data center is outsourced, in which case facilities management refers to the management of the outsourcing contract.
The purpose of event management is to manage events throughout their life cycle. This life cycle of activities to detect events, make sense of them, and determine the appropriate control action is coordinated by the event management process. Event management is therefore the basis for operational monitoring and control. If events are programmed to communicate operational information, as well as warnings and exceptions, they can be used as a basis for automating many routine operations management activities. For example, executing scripts on remote devices, or submitting jobs for processing, or even dynamically balancing the demand for a service across multiple devices to enhance performance. The objectives of the event management process focus on three core areas: detecting that an event has occurred, then interpreting the event in terms of its significance, and finally taking the appropriate course of action to deal with it. More specifically, they include detecting all changes of state that have significance for the management of a configuration item or IT service, determining the appropriate control action for events and ensure these are communicated to the appropriate functions, providing the trigger or entry point for the execution of many service operation processes and operations management activities, providing the means to compare actual operating performance and behaviour against design standards and service level agreements, providing a basis for service assurance and reporting, and service improvement. There are three main types of events that we need to consider, namely informational events, warning events, and exception events. It should be stressed, though, that there are other types of event to consider which are beyond our scope currently. Informational events are events that have occurred. They need to be logged, but they do not require any intervention by IT staff members. Examples are: a scheduled workload has completed, or a user has logged in to use an application, or an email has been delivered to a recipient. It may be required as a form of email journaling, which is a compliance requirement of Sarbanes-Oxley. Warning events indicate that an event has occurred which is not standard, but is not exceptional either. A warning event has exceeded usually an agreed threshold, which may be in place to trigger closer monitoring or because some intervention is required by IT staff. Examples are: a server's memory utilization reaches within 5% of its highest acceptable performance level, or the completion time of a transaction is 10% longer than normal. Exception events are the more significant of the three event types. These are generated when a significant event has occurred and direct intervention is usually required. Examples are: a user attempts to log on to an application with the incorrect password. An unusual situation has occurred in a business process that may indicate an exception requiring further business investigation. A device's processor utilization has exceeded the acceptable utilization rate. A PC scan reveals the installation of unauthorized software.
The purpose of incident management is to restore normal service operation as quickly as possible and minimize the adverse impact on business operations, thus ensuring that agreed levels of service quality are maintained. Normal service operation is defined as an operational state where services and configuration items are performing within their agreed service and operational levels as defined in their respective agreements. The objectives of the incident management process are to ensure that standardized methods and procedures are used for efficient and prompt response, analysis, documentation, ongoing management, and reporting of incidents. Increase visibility and communication of incidents to business and IT support staff. Enhance business perception of IT through use of a professional approach in quickly resolving and communicating incidents when they occur. Align incident management activities and priorities with those of the business. Maintain user satisfaction with the quality of IT services. The scope of the incident management process includes any event which disrupts or which could disrupt a service. This includes events which are communicated directly by users through the service desk or via event management. Incidents can also be reported and/or logged by technical staff. Whilst both incidents and service requests are reported to the service desk, this does not mean that they are the same. Service requests do not represent a disruption to agreed service, but are a way of meeting the customer's needs and may be addressing an agreed target in a service-level agreement. Service requests are dealt with by the request fulfillment process. There are some basic aspects that need to be taken into account and decided upon when considering incident management. Timescales are a major consideration when dealing with incidents. They must be agreed for all incident handling stages. These will differ depending upon the priority level of the incident, based upon the overall incident response and resolution targets within service-level agreements, and captured as targets within any supporting operational level agreements and underpinning contracts. These timescales should be communicated to all relevant support groups. As many incidents are not new, they involve dealing with something that has happened before and may well happen again. For this reason, many organizations will find it helpful to predefine standard incident models and apply them to appropriate incidents when they occur. An incident model is a way of predefining the steps that should be taken to handle a particular type of incident in an agreed way. Support tools could then be used to manage the required process. This will ensure that standard incidents are handled in a predefined path and within predefined timescales. A definition of what constitutes a major incident must be agreed. A separate procedure with shorter timescales and greater urgency must be used for major incidents. The definition of a major incident should ideally be mapped onto the overall incident prioritization scheme. Where necessary, the major incident procedure should include the establishment of a separate major incident team under the direct leadership of the incident manager, formulated to concentrate on this incident alone to ensure that adequate resources and focus are provided to finding a swift resolution. Finally, incidents should be tracked throughout their life cycle to support proper handling and reporting on the status of incidents. Within the incident management system, status codes may be linked to incidents to indicate where they are in relation to the life cycle. Examples are open, where an incident has been recognized but not yet assigned to a support resource for resolution. In progress, where the incident is in the process of being investigated and resolved. Resolved, where a resolution has been put in place for the incident but normal state service operations has not yet been validated by the business or end user. And closed, where the user or business has agreed that the incident has been resolved and that normal state operations have been restored. It is imperative that these status be used consistently, otherwise the value of the management information used within service operation and in continual service.
With these concepts in place, we can now review the incident management procedure. As mentioned earlier, incidents may be recognised from many sources, such as technical staff, or detected and reported by event monitoring tools, communications from users, usually via a telephone call to the service desk, or reported by third-party suppliers and partners. While work cannot begin on dealing with an incident until it is known that an incident has occurred, it is usually unacceptable from a business perspective to wait until a user is impacted and contacts the service desk. As far as possible, all key components should be monitored so that failures or potential failures are detected early. This means that the incident management process can be started quickly. All incidents must be fully logged and date time-stamped, regardless of whether they are raised through a service desk telephone call, automatically detected via an event alert, or from any other sources. All relevant information relating to the nature of the incident must be logged, so that a full historical record is maintained. and so that if the incident has to be referred to other support groups, they will have all relevant information to hand to assist them. If there is a dedicated request fulfillment process and the incident is actually a service request, the incident will be passed to request fulfillment. Otherwise, it will be handled according to the defined request fulfillment process. Part of the initial logging must be to allocate suitable incident categorization coding so that the exact type of incident is recorded. This will be important later when looking at incident types or frequencies to establish trends for use in problem management, supplier management, and other service management activities. Another important aspect of logging every incident is to agree and allocate an appropriate prioritization code, as this will determine how the incident is handled both by support tools and support staff. Priority can normally be determined by taking into account two key factors, namely the urgency of the incident and the level of business impact it is causing. An indication of urgency is how quickly the business needs a resolution, for example, before a penalty clause becomes active. An indication of impact is often, but not always, the number of users being affected. In some cases, and very importantly, the loss of service to a single user can have a major business impact, for example, payroll at month end. Should an incident be prioritized as a major incident, then the major incident procedure will be applied and responsibility for the incident passed to this team. If the incident has been routed via the service desk analyst must carry out initial diagnosis, typically while the user is still on the telephone if the call is raised in this way, to try to discover the full symptoms of the incident and to determine exactly what has gone wrong and how to correct it. However, it might be the case that the call requires escalating. There are two forms of escalation available. Firstly, functional escalation, for when it becomes clear that the service desk is unable to resolve the incident itself, or when target times for first point resolution have been exceeded, whichever comes first. The incident must be immediately escalated for further support. If the organisation has a hierarchy of support groups with more time or specialist skills that the service desk believes can resolve the incident, it should refer the incident to the appropriate next-level support group in that hierarchy. If incidents are of a serious nature, for example high-priority incidents, the appropriate IT managers must be notified, for informational purposes at least. Hierarchic escalation is also used if the investigation and diagnosis and resolution and recovery steps are taking too long or proving too difficult. Hierarchic escalation should continue up the management chain, so that senior managers are aware and can be prepared and take any necessary action. Regardless of where an incident is referred to during its life, ownership of the incident must remain with the service desk at all times. The service desk remains responsible for tracking progress, keeping users informed, and ultimately for incident closure. A reported incident is likely to require some degree of investigation and diagnosis. Each of the support groups involved with the incident handling will investigate and diagnose what has gone wrong, and all such activities, including details of any actions taken to try to resolve or recreate the incident, should be fully documented in the incident record, so that a complete historical record of all activities is maintained at all times. When a potential resolution has been identified, this should be applied and tested. The specific actions to be undertaken and the people who will be involved in taking the recovery actions may vary, depending upon the nature of the fault. When a resolution has been found, sufficient testing must be performed to ensure that recovery action is complete and that normal state service operation has been restored. Incident management must coordinate the activities and liaise with all parties involved. The incident record must be updated with all relevant information and details, so that a full history is maintained, and the resolving group should pass the incident back to the service desk for closure action. The service desk should check that the incident is fully resolved and that the users are satisfied and willing to agree the incident can be closed. There are a number of interfaces that incident management process will work very closely with. In service design, the process interacts with service level management by providing reports that enable service level management to review service level agreements objectively and regularly. Information security management will be provided with security-related incident information, as needed, to support service design activities and gain a full picture of the effectiveness of the security measures as a whole, based on an insight into all security incidents. Capacity management will be triggered by incident management for performance monitoring, where there appears to be a performance problem. Capacity management may develop workarounds for incidents. Availability management will use incident management data to determine the availability of IT services and look at where the incident lifecycle can be improved. In service transition, the process interacts with service asset and configuration management, providing the data used to identify and progress incidents. One of the uses of the configuration management system is to identify faulty equipment and to assess the impact of an incident. Where a change is required to implement a workaround or resolution, this will need to be logged as a request for change and progressed through change management. In turn, incident management is able to detect and resolve incidents that arise from failed changes. And finally, within service operation, the process will interact with problem management, where, for some incidents, it will be appropriate to involve problem management to investigate and resolve the underlying cause to prevent or reduce the impact of recurrence. Access management will raise incidents when unauthorized access attempts and security breaches have been detected.
The term service request is used as a generic description for many different types of demands that are placed upon the IT organization by the users. Many of these are typically requests for small changes that are low risk, frequently performed, low cost, etc. For example, a request to change a password, a request to install an additional software application onto a particular workstation, a request to relocate some items of desktop equipment, or maybe just a request for information. Their scale and frequent low-risk nature means that they are better handled by a separate process rather than being allowed to congest and obstruct the normal incident and change management processes. Effective request fulfillment has a very important role in maintaining end-user satisfaction with the services they are receiving and can directly impact how well IT is perceived throughout the business. The purpose of request fulfillment is therefore very straightforward. It is the process responsible for managing the lifecycle of all service requests from the users. The objectives of the request fulfillment process are focused on maximizing user satisfaction. They include maintaining user and customer satisfaction through efficient and professional handling of all service requests, providing a channel for users to request and receive standard services for which a predefined authorization and qualification process exists, providing information to users and customers about the availability of services and the procedure for obtaining them, sourcing and delivering the components of requested standard services such as software licenses and software media, and to assist with general information, complaints or comments. The scope of the request fulfillment process is not as clearly defined as other processes, as it will vary from organization to organization. The process needed to fulfill a request will vary depending upon exactly what is being requested, but can usually be broken down into a set of activities that have to be performed. For each request, these activities should be documented into a request model. In an organization where large numbers of service requests have to be handled, and where the actions to be taken to fulfill those requests are very varied or specialized, it may be appropriate to handle service requests as a completely separate work stream, and to record and manage them as a separate record type. It will be up to each organization to decide and document which service requests it will handle through the request fulfillment process and which will have to go through other processes, such as business relationship management, for dealing with requests for new or changed services. Some service requests will occur frequently and will require handling consistently in order to meet agreed service levels. To assist this, many organizations will wish to create predefined request models, which typically include one or more standard changes in order to complete fulfillment activities. This is similar in concept to the idea of incident models already described in incident management, but applied to service requests.
Access management is the process of granting authorized users the right to use a service, while preventing access to non-authorized users. The process has also been referred to as rights management or identity management in different organizations. Where the information security management process focuses on designing and delivering an information security policy, access management is the practical application of that policy. The purpose of access management, therefore, is to provide the right for users to be able to use a service or group of services. It is therefore the execution of policies and actions defined in information security management. The objectives of the request fulfillment process are to manage access to services based on policies and actions defined by the information security management process, efficiently respond to requests for granting access to services, changing access rights or restricting access, ensuring that the rights being provided or changed are properly granted, oversee access to services, and ensure rights being provided are not improperly used. The scope of the access management process is closely tied to the information security policy. Access management is effectively the execution of that policy, and it enables the organization to manage the confidentiality, availability, and integrity of the organization's data and intellectual property. Access management ensures that users are given the right to use a service, but it does not ensure that this access is available at all agreed times. This is provided by availability management.
Problem management is the process responsible for managing the life cycle of all problems. ITIL defines a problem as the underlying cause of one or more incidents. The purpose of problem management is to manage the life cycle of all problems from first identification through further investigation, documentation, and eventual removal. Problem management seeks to minimize the adverse impact of incidents and problems on the business that are caused by underlying errors within the IT infrastructure and to proactively prevent recurrence of incidents related to these errors. In order to achieve this, problem management seeks to get to the root cause of incidents, document and communicate known errors, and initiate actions to improve or correct the situation. With this in mind, the objectives of the problem management process are to prevent problems and resulting incidents from happening, eliminate recurring incidents, minimize the impact of incidents that cannot be prevented. The scope of the problem management process is quite wide-ranging. It will include the activities required to diagnose the root cause of incidents and to determine the resolution to those problems. It is also responsible for ensuring that the resolution is implemented through the appropriate control procedures, especially change management and release and deployment management. Problem management will also maintain information about problems and the appropriate workarounds and resolutions, so that the organization is able to reduce the number and impact of incidents over time. Although incident and problem management are separate processes, they are closely related and will typically use the same tools and may use similar categorization, impact, and priority coding systems. These will ensure effective communication when dealing with related incidents and problems. The problem management process has both reactive and proactive aspects. Reactive problem management is concerned with solving problems in response to one or more incidents. Proactive problem management is concerned with identifying and solving problems and known errors before further incidents related to them can occur again. For these reasons, the scope is a little wider than that of other processes. There are some important concepts of problem management that must be taken into account from the outset. These include the reactive and proactive problem management activities. Both reactive and proactive problem management activities seek to raise problems, manage them through the problem management process, find the underlying causes of the incidents they are associated with, and prevent future recurrences of those incidents. The difference between reactive and proactive problem management lies in how the problem management process is triggered. With reactive problem management, process activities will typically be triggered in reaction to an incident that has taken place. Reactive problem management complements incident management activities by focusing on the underlying cause of an incident to prevent its recurrence and identifying workarounds when necessary. With proactive problem management, process activities are triggered by activities seeking to improve services. One example might be trend analysis activities to find common underlying causes of historical incidents that took place to prevent their recurrence. Proactive problem management complements CSI activities by helping to identify workarounds and improvement actions that can improve the quality of a service. We also need to consider problem models. Many problems will be unique and will require handling in an individual way, but it is conceivable that some incidents may recur because of dormant or underlying problems. For example, where the cost of a permanent resolution will be high and a decision has been taken not to go ahead with an expensive solution, but to live with the problem. Where an application has reached the end of its useful life and is now classed as fated. Finally, we need to be clear on certain definitions also. A problem is defined as the unknown cause of one or more incidents raised by the service desk. In trying to find a solution, a workaround may be applied, which is a temporary way of overcoming a difficulty and restoring full or limited service. A known error is defined as a problem with a documented root cause and workaround. A known error record should identify the problem record it relates to and document the status of actions being taken to resolve the problem, its root cause, and workaround. All known error records should be stored in the known errors database.
Let us now consider the problem management process flow for handling a recognized problem. There are a number of ways of detecting problems, some reactive, some proactive. Various sources could include notification from the service desk or through incident management, where an incident needs to be escalated, or through an event having been detected repeatedly, or even through a communication from a supplier. Regardless of the detection method, all the relevant details of the problem must be recorded so that a full historic record exists. A cross-reference must be made to the incident which initiated the problem record. Problems should be categorized in the same way as incidents, and it is advisable to use the same coding system so that the true nature of the problem can be easily traced in the future and meaningful management information can be obtained. This also allows for incidents and problems to be more readily matched. Problems should be prioritized the same way, using the same reasons as incidents. The frequency and impact of related incidents must also be taken into account. The coding system combines incident impact with urgency to give an overall priority level and can be used to prioritize problems. At this stage, an investigation should be conducted to try to diagnose the root cause of the problem. The speed and nature of this investigation will vary depending upon the impact, severity, and urgency of the problem. There are a number of useful problem-solving techniques that can be used to help diagnose and resolve problems, and these should be used as appropriate. The configuration management system must be used to help determine the level of impact and pinpoint and diagnose the exact point of failure, and the known errors database should also be accessed. In some cases, it may be possible to find a workaround to the incidents caused by the problem, a temporary way of overcoming the difficulties. When a workaround is found, it is therefore important that the problem record remains open and details of the workaround are documented within the problem record. Incident management should also be updated as to any workaround that is found, as this may be of use in future calls. A known error is defined as a problem with a documented root cause and workaround. The known error record should identify the problem record it relates to and document the status of actions being taken to resolve the problem, its root cause and workaround. All known error records should be stored in the known errors database. If a change is required to resolve the problem, then a request for change should be raised and passed to change management, with a breakdown of the cost and effort expected to resolve the problem. Once a root cause has been found and a solution to remove it has been developed, it should be applied to resolve the problem. When a final resolution has been applied, the problem record should be formally closed, as should any related incident records that are still open. After every major problem as determined by the organization's priority system, and while memories are still fresh, a review should be conducted to learn any lessons for the future. There are a number of other processes that problem management will interface with. In service strategy, it will work closely with financial management for IT services, as it assists in assessing the impact of proposed resolutions or workarounds, as well as pain value analysis. Problem management provides management information about the cost of resolving and preventing problems, which is used as input into the budgeting and accounting systems and total cost of ownership calculations. There are a number of other processes that problem management will interface with. In service design, it will work closely with availability management, which is involved with determining how to reduce downtime and increase uptime. Capacity management will help investigate certain performance-related problems, as well as helping in assessing proactive measures. Problem management provides management information relative to the quality of decisions made during the capacity planning process. For IT service continuity management, problem management acts as an entry point where a significant problem is not resolved before it starts to have a major impact on the business. The occurrence of incidents and problems affects the level of service delivery measured by service level management. Problem management contributes to improvements in service levels, and its management information is used as the basis of some of the service level agreement review components. Service level management also provides parameters within which problem management works. There are a number of other processes that problem management will interface with. In service transition, it will work closely with change management, as all resolutions or workarounds that require a change to a CI are submitted through change management through a request for change. Change management will monitor the progress of these changes and keep problem management advised. Problem management is also involved in rectifying the situation caused by failed changes. Service asset and configuration management will provide the configuration management system used by problem management to identify faulty configuration items and also to determine the impact of problems and resolutions. Release and deployment management will be responsible for deploying problem fixes out into the live environment. It also assists in ensuring that the associated known errors are transferred into the live known error database. Problem management will help resolve problems caused by faults during the release process. In knowledge management, the service knowledge management system can be used to form the basis for the known errors database and hold or integrate with the problem records. Finally, in continual service improvement, it will work closely with the 7-step improvement process, as the occurrence of incidents and problems provides a basis for identifying opportunities for service improvement and adding them to the CSI register. Proactive problem management activities may also identify underlying problems and service issues that, if addressed, can contribute to increases in service quality and end-user or customer satisfaction.
Selecting and adopting the best practice as recommended in service operations stage of the lifecycle will assist organizations in delivering significant benefits. Adopting and implementing standard and consistent approaches for service operation will reduce unplanned labor and costs for both the business and IT through optimized handling of service outages and identification of their root causes. Reduce the duration and frequency of service outages, which will allow the business to take full advantage of the value created by the services they are receiving. Provide operational results and data that can be used by other ITIL processes to improve services continually and provide justification for investing in ongoing service improvement activities and supporting technologies. Meet the goals and objectives of the organization's security policy by ensuring that IT services will be accessed only by those authorized to use them. Provide quick and effective access to standard services which business staff can use to improve their productivity or the quality of business services and products. Provide a basis for automated operations, thus increasing efficiencies and allowing expensive human resources to be used for more innovative work, such as designing new or improved functionality or defining new ways in which the business can exploit technology for increased competitive advantage.
This completes the lessons within this module. You should take the opportunity to reflect back against the module objectives. Consider whether these objectives have been met and whether you need to review any of the lessons. When you are comfortable with having completed the module learning, you can progress to the next module.